Our session chairman for this session is Mr. Ian Bose. Mr. Ian Bose is advisor and head of vessel performance management at Great Eastern Shipping Company and is responsible for monitoring and enhancing fuel efficiency of fleet vessels and reduction of GHG emissions. He is a member of the governing board and chairman of the Academic Council of Great Eastern Institute of Maritime Studies. Mr. Bose holds extra first-class engineer COC from DOT UK. He is the current chairman of Technical Committee of Indian National Shipowners Association. He has authored a book titled Energy Efficiency and Ships, which has been highly acclaimed by professional bodies nationally and internationally. He has been representing Government of India at Marine Environment Protection Committee and diplomatic conferences of IMO for over 2 decades. Ladies and gentlemen, please welcome Mr. Ian Bose.
Good afternoon to all. Welcome to this Marine Environment Technical session. I would request all the 3 authors to please take their seats on the dais. Our first speaker is Mr. Sharad Sinha. His topic is greenhouse gas emission, its impacts and measures. Mr. Sinha is a DMET graduate and he began his sea career in 1988. He has served in Great Eastern Shipping Company and Chogul Steamship before moving on to Denholm Ship Management. And he has served as chief engineer till 2001. He joined Reliance Ports and Terminals in 2001 before moving to Wärtsilä India in 2004. Mr. Sinha headed Wärtsilä India Ship Power Division until 2014, responsible for Wärtsilä's business in India, Bangladesh and Sri Lanka. He is currently based in Dubai, where he currently works as Segment Sales General Manager, Merchant and Gas Carriers, responsible for Segment's business for Middle East and Southeast Asia. Now I request Mr. Sharad Sinha to make his presentation, and one request to all the authors is to stick to your time schedule of 20 minutes. We are running behind time. So Mr. Sinha, please.
Well, very good afternoon to all of you, and thank you, Mr. Bose, for your kind words. For me personally, it is really a pleasure today and privilege to be here in front of all of you, my colleagues, my friends, every one of you, and I'm so happy to be here today. Well, when I was speaking to the current head of Marine Solutions here in Wärtsilä, India, about INMARCO, and we were talking about what shall we actually try to talk about during this session. As you all know, in Wärtsilä we have many services and solutions and products and so on. But is something that we are now trying to do for the industry is something should be the right subject. And I thought nothing better than this. If we talk about the gas emissions, it was also a very interesting session, previous one, when we were still talking about quite similar subject, as to say. But let's see if we are talking the same thing or maybe slightly differently, or also trying to tell you how can the industry, the people like Wärtsilä are able to contribute to what is required to be done in future to be able to do what is intended to be done. I have tried to focus today more on gas emissions and not much, I will still be covering a little bit on sulfur and NOx, but I wanted to draw your attention to gas emissions more. And the reason for that is because today, by the virtue of my being in Middle East, I also come across many people in the Western world who have already been thinking about the future, the nature, the climate. But here in our beautiful country, do we actually think? We probably know it, but do we actually look at each other and think about whose job it is to actually do this? And this is my intention today, to try and bring everybody together to make it together. Well, IMO has, of course, now we know that has a strategy of reducing the CO2 emissions by 50% by 2050 from the levels which were there in 2008. But it's a strategy today. It's not a convention, it's not a law, or it's not a rule that we need to follow. Of course, there are many people in the world who have already decided to do it. There are many shipping companies, I can name a few maybe, like CMA, CGM, or Maersk, or MSC, who already claim that they have reduced the CO2 emissions from the ships by close to 50% today, from what they were doing maybe 5 or 10 years back. But are the others following the trend? Do we actually have to do it? And if we have to do it, then what is to be done? And the reason why I'm focusing on this is because it has a global impact. Unlike NOx or SOx, if we talk about NOx and SOx, well, when I was putting this picture on my presentation today, I was wondering if I'm actually starting a little bit not on a nice note. And I thought about it 10 times, and I decided that this is exactly the picture I wanted to have. Because time has come that we need to think about it, that it's not someone else's problem, it's all of our problems, and we all have to do something about it. This picture, of course, is from a neighboring country, but we know that the situation is not so much different than many parts of India, maybe in the north, where I come from also. This one is a very recent one. We know it down south in India, what happened with the floods. And the amount of losses that happened over the short period of 15 days is phenomenal. People will not be able to recover their savings for a lifetime. But is it something which is a natural phenomenon? Is it something that God created? Is it something that we cannot avoid? No. It is very much that we have created, actually, we have contributed, all of us, and there is a possibility that we are able to correct it. I will just spend a few minutes only on emissions before I move on to what I'm trying to talk to you today. Basically, any engine which is burning a fuel, we know, whether in car or bus or truck or lorry or ship or whatever, it will have an emission. But there are two types of emissions which we categorize into category 1 and category 2. Category 1 is basically the local, what we talked about already, the NOx and the SOx. So wherever there is an emission, you have an impact there only. It's a very local one, and it has a direct impact on our health. It's immediately impacting the people. And this is why today we have the ECA areas, where the countries, they recognize that these emissions are having an impact on our health. And we would not like to have it happen. And that's why they have controlled it. And today there's a regulation for which we have to comply with. But category 2 is the greenhouse gas emissions, CO2 and methane. And this is not a local criteria. It has a global impact. Doesn't matter where you are, you will change the climate of the world. And this is why this is more important. Having said CO2, we also should remember that we have methane, which is also getting emitted from the engines that we are using today on gas. And also let us remember that methane is 28 times more dangerous than CO2 when it comes to the climate. And it is necessary for us to also control the methane emission in addition to CO2. Well, this is something which we know. And we know the sulfur dioxide, we know the nitrogen oxide, and also we know the particulates. And I think more or less we have learned how we are going to, if we talk about only the shipping now. We know the sulfur limit which is going to come into place. We know that we have to comply with tier 3. And I think we have the solutions now. We know every one of us have decided what we want to do. If we want to move to LNG and kill all these issues with one go, we can do that. If we don't want to do that, we can wait for low sulfur, as it was discussed also in the last session, and hope for the best. We don't know the pricing, we don't know the availability or whatever. Or, of course, the simplest solution also could be that, yes, we know the fuel today, and we use the NOx, and we use NOx reducer, and we use the scrubbers. And we comply with everything. So I think we have a solution to this, more or less, and we don't need to. But can we say the same thing for CO2? Can we say today that we know what we need to do for reducing the CO2 or to meet the criteria or to reach the target of 50% reduction by 2050? And my answer to that would be maybe, maybe not, maybe yes, maybe no. But that's what we need to do. And that's where probably Vatsla or many companies like us come into picture. It's our responsibility to actually cater to the industry, which needs these solutions from us to be able to reach to that goal. And that's what we are trying to do continuously. If we just talk about the engines only, it's not only, let's say, I talked about the methane, and methane slip, we have heard it many, many times at many, many forums. Yes, it's a big problem, and also, as I said, it's 28 times more dangerous than CO2. But we have been reducing the methane emission from our engines for a very long time. And it's already reached to that stage where it's very, very less now. And there's a commitment which we have given ourselves short-term and long-term. And if we look at just the short-term, 2015 to 2020, we will still further reduce the methane or the greenhouse gas emissions from our engines by 15%. So there is an effort continuously going on to reduce the CO2. The question is it enough? Do you actually just reduce the CO2 emissions from the engines and you still reach to that goal? To me, that answer is no right now. And one of the reasons is this. We heard about it that if you use LNG as fuel, or in a dual fuel engine or on a gas engine maybe, you just take away all SOx and you take away the particulates completely. And you also reduce the NOx to 85% and you meet IMO Tier 3 requirements. So you've taken care of category 1 of emissions. But you have reduced CO2 only by 25% as on today from these engines also, so you're still not there. Yes, the technology is increasing. We will probably, over the years, increase it a little bit more. But we have a long-term goal. And how do we do that? Can you help me with this? I can't change my slide. Well, let me just talk about it in the meantime. There is one way, of course, we know that we need to improve on the efficiency of engines. Yes, you can, and you will burn less fuel. The second is you use LNG as fuel, so you don't emit so many CO2 into the market. But I want to show you one more thing, which we don't see today, is the entire ecosystem. We think of a ship as a ship alone, as an entity alone. It has nothing to do with the rest of the ships, or the ports, or the transportation system, or the logistics, or something. We leave a port and we go to the next port, and we wait there. In the meantime, what we did, we went full steam, and we went full ahead, and we burnt a lot of fuel. But think of a scenario when a ship and a port or a logistics company are all connected together, and you do the things at the right time. And this is where the new technology, artificial intelligence, we've been talking about it all the time now, which is becoming a buzzword, a smart ship, a smart port, a smart shipping. And these are not just buzzwords now. They're actually becoming a reality. The ports, the ships, everything is connected together. Or they will be connected together. There are many people who have moved into that direction. So what happens? You have an efficient ship, you burn a good fuel, And then you are connected together with the entire ecosystem. And all these measures that you have taken will make sure that you transport that much of cargo by burning that much of less fuel. And as soon as you burn less fuel, you have emitted that much of less CO2. Well, we are talking about the artificial intelligence, and we see something over here already. So it's still, it's a man which has to make the things happen. But I hope it works. Otherwise, I just have to do this and entertain you this way itself. Having said that, we burn the fuel in the engines, yes. We have to go to the port, yes. We want to reach there in time, yes. We did all this together, the cloud system, the satellite connectivity. And we have, I hope you guys have heard about a company called Eniram, which became part of Versla about 2.5 years back. And we just do the artificial intelligence. We take all the data from the ship. It's about the hull fouling, it's about the propeller fouling, it's about the trim, it's about how much cargo you are loaded, how much is the ballast, what is the weather condition, what route you're taking, what is the safest way of doing it. It goes into the system, which is analyzed, it goes back into the ship, and the course correction is taken. And you have achieved that 5 to 7% fuel efficiency. The second system, thank you so much. I think this is what I was talking about a little bit. The line at the bottom is, how do we actually connect the ecosystem together? But then you have a ship. You have the assets, you have the propeller, you have a very good ship, you have a hull, you have a propeller which is efficient. You designed it perfectly. And you see a good flower. And I see a good ship over here. Okay, there it is. Sorry about it. Yeah. But then do you actually connect that left circle with the right circle is something which I talked about now. The voyage optimization, the artificial intelligence. How many of us are actually doing it today? Yes, in Mumbai, when you leave from your office in South Mumbai and you have to go to Navi Mumbai, you just go up on the freeway and you reach there. But when I go to my office or my home from office in Dubai, where I live now, I have 10 different ways, and I always use Google Map to know what do I do at that point of time. Do we actually do that for the ships today? No. And this is what actually helps the entire technology together with what we have been seeing together for many, many years now. And I hope it works again, or it does, yeah. This is something what I was telling you. If you're able to take the data, you're able to make those corrections, and you're able to improve on the efficiencies. And this is just an example. It's not a detailed study that I'm showing you, but something which we have done already for a container ship, which is sailing from Suez Canal to Singapore. And it's a big ship, and it's carrying so many containers, but the same containers, if you do this, you can save so much of CO2, you can save so much of fuel. And of course, it's also money in the end for the ship owner or the charter or whoever it is. And these are the means which will actually add for us to reduce the emissions or the CO2 emissions that I'm focusing today. This is another one. We have also one company, part of our organization now, called Transas, which is complementing to Eniram, and they also have these various artificial intelligence solutions where you have a route mapping. ECDIS we all probably are using quite a lot, and we also have this maneuvering in the channels, like in English Channel or when you're making a port, when the chances of any accidents or anything is reduced dramatically. And of course, in the end, you save environment. Well, this is something which we have been talking about. What do we do? Of course, I have shown some biofuels, methanol, LPG. There are ship engines now running on LPG. We are talking about hydrogen. And hydrogen, when you burn hydrogen in the engines, the only thing you emit is water. So how beautiful it will be. Perfect. And there will be work which will happen, methanol. There are many solutions which will come into future. Today they are not there, but perhaps LNG, 5 years back, if you're standing on the same dais, we were very unsure. What will happen with LNG? The same questions will be after 5 years, yeah, we have a solution already with LPG or hydrogen or something like that. Yeah, I'm just finishing. Well, just to give you a glimpse, hybrid Tesla car, yes, but I see a lot of ships now coming with hybrid solutions. You have retrofits, you have the new ships coming with hybrids, and batteries are coming. Shore power, I think this is a small contributor. Many states in US now, it's mandatory that when you go to the port, you have to use the shore power. And when you use the shore power is already green power, so you are actually not emitting anything. I just want to give you 2 more minutes, Mr. Bose. We have a tanker, say, carrying crude oil. And we know that there is an emission which happens every day, which just goes into the atmosphere. But we have a solution today, in Vatsla, we have a solution today where we actually recover it and you burn it back into a dual fuel engine or a gas engine. And you actually save almost 5 to 7 or 10% fuel. This is applicable, of course, only for tankers, and you have to burn it in an LNG engine. Well, last week or last week, there was already a resolution by IMO, and they have moved on from April now. They have now given some dates or the guidelines on how we are going to actually achieve. There's a short term, there's a mid term, and there is going to be a long term. There are no details, at least not to my knowledge. Maybe Mr. Bose knows this better than me. But there will be more and more to come. But we cannot wait for IMO to tell us what to do. We have to do it ourselves. Well, this is my favorite. It's a beautiful ship. This is the future. And I hope one day we will see this. We have the ship completely connected by satellite. You see a cloud. You see the data which is on the right-hand top corner. You also see the sails there, which was always there for many, many years. In the aft, you have wind turbines, 3 of them, vertical ones. You use the wind to convert it to energy. It's an electric ship. It also has hybrid. And on the sides, you also see the solar panels, and also in the front. Many of these will become a reality in near future. And once we do that, we will have this beautiful nature, our own world, for us to enjoy, our grandchildren to enjoy. Thank you so much.
Thank you, Mr. Sinha.